two formula to memorize. So the first one is the formula for pH, which is negative log H3O plus or H plus. The second one is pOH. We use pOH when we don't have the concentration of H3O plus. We only have the concentration of OH minus, so that we can use this. And we have another formula, which is the relation between pH and pOH. So we know that pH plus pOH is equal to 14. Alright, so now let's look at one of the example. So let's say we want to calculate the pH of a strong acid, maybe. .5 molar chloric acid. So first of all, when we have a chloric acid, we know that it is a strong acid. So first we need to write the dissociation equation. So HCl equals dissociate in water, because it is a strong, so the arrow is one-headed or non-reversible. Okay, so initially we have 0.5 molar chloric acid and we don't have any product form. The changes, because strong acid is completely dissociate, so all the chloric acid will dissolve or will dissociate, and it will gain. And after the reaction, this one 0, this one 0.5 molar, and this one also 0.5 molar. Okay, so to calculate the pH, we have a formula, which is pH is equal to negative log H3O plus. Okay, and we have the concentration, we have H3O plus, and this is the final concentration. So because of that, we can straight away apply the formula, and the answer will be 0.3. Okay, so this is how we solve the problem that relate to a strong acid. Okay, now what about strong base? So let's say I want you to calculate the pH of 0.5 molar sodium hydroxide. We know that sodium hydroxide is an example of strong base. So first we need to write the equation. So the sodium hydroxide okay, so this is the equation, and now we put the information. So initially we have 0.5 molar, and this is 0, this is 0. The changes, since it is a strong base, so all will dissolve. And the final so to calculate the pH, we need the concentration of H3O plus, but in this case we don't have H3O plus, we only have OH minus. Okay, so because of that, we cannot straight away calculate the pH, but we can calculate the pOH. So first we calculate the pOH, which is negative log OH minus, because we have the concentration. .30. This is the pOH. The question asks you to determine the pH. So how to determine the pH? We have a formula. So pH pH is equal to 14 minus 0.30, which is 13.69. Okay, alright. So this is how to calculate the pH of a strong acid and strong base, right? Okay. So now we want to calculate the pH of a weak acid and weak base. There is a slightly different for calculation of the pH. Let's say we want to calculate the pH of 0.5 molar HCN, okay, and the Ka given is 4.010 to the power of negative 10. Okay, and this is for the alright. Now let's look at the question. So HCN is an acid, and if we are given the value of Ka, meaning that it is a weak acid. So first we need to write the dissociation. HCN equals okay. So initially we have 0.5 molar. This is 0. This is 0 because weak acid is partially dissociate, so we do not know the actual concentration dissociate. So the changes is negative X, this is positive X, this is positive X. So and the final we are given the Ka value. So how to use the Ka? So first of all, we can write the Ka for this acid is H3O plus because it's only involved the aqueous state. Water does not included because it is in a liquid state. Okay, we already have the value of Ka, which is 4.010 to the power of negative 10 is equal to x squared over 0.5 minus x. Okay, so how did I get this value? It is based on a final concentration which is at equilibrium lah. Alright, so now let's look at our Ka value. The value is very small because it is negative 10. Because of that, we can write a statement. Okay, since the Ka value is very small, which is 4.010 to the power of negative 10, which is very small. So thus, we can conclude or we can assume that 0.5 minus x approximately to 0.5. Okay, alright, so now we will go to the next step. So how to get, so now 4.010 to the power of negative 10 is equal to x squared divided by 0.5. So from there you can get the value of x, which is the square root of 410 to the power of negative 10 times 0.5 which is 1.4110 to the power of negative 5. So actually the X value is equal to the concentration of the H3O plus and also the concentration of cyanide. Okay, so that we can take it as the concentration of H3O plus. So the pH is negative log H3 H3O plus, which is negative log sama dengan 4.85. So this is the pH of the weak base. Weak acid. Alright, so this is how we calculate. Alright, now maybe we can take another example. Right? So how to calculate the pH of a weak base? Okay, let's say calculate the pH of 0.5 molar ammonia, and the Kb given is 1.8 10 to the power of negative 5. Okay, since the Kb is given, meaning that ammonia is a weak base. So first we need to write the equation for the weak base. Ammonia plus water produce and then the initial concentration and the changes is because we do not know the actual amount that change. So from here we can write the Kb expression when we insert the value, maybe we can get since this value is very small, so we can write a statement since now the Kb is very small, so thus 0.5 minus X equivalent to 0.5 molar lah, because we are talking about concentration. Okay, now next. Okay, so we know that 1.8 10 to the power of negative 5 is equal to x squared over 0.5. So x would be the square root of 1.8 10 to the power of negative 5 times 0.5. Okay, now this X value is equal to the concentration of ammonium ion and equal to the concentration of hydroxide ion. So because of that, we cannot straight away calculate the pH. We have to calculate the POH first, because we have the OH minus. So POH equal to negative log OH minus, okay, because we only have this. So negative log you will get 2.52. And how to calculate the pH? So by using the formula, 11, you will get 11.47.